Hello, welcome back to another lecture. I hope you are well. We're going to continue with the load and load path. We talked about dead load, live load, and this lecture we're going to talk about rain load. Let's start out with an example. While we go through the example, we're going to explain the code. Take a look at this example on the board. We have this roof that is, let me get to it. It's about 3,000 square feet, the roof is, and the rainfall rate intensity, which is based on the area that the site is, and that's 3.75 inch per hour. And the type of scupper that you use on a roof is a 6-inch wide B-channel scupper. And then there's something called DS, which we're going to explain in a second, which is the vertical distance from the primary roof drain to the inlet of the scupper. I call it static head, and that's DS, and that's 3 inches. And let's look at the code. There's a bunch of formula we like to go over. And if you take a look at the code right here at ASCE C8.1, and they give you the Q is equal 0.0104 AI, and where A is the roof area that service that drainage system, and I is a design rainfall intensity as specified by the code of the local code, where it depends on the area. If you live in a desert or live in some places it rains all the time, it's a big difference. And Q, here's the important thing. The Q is in gallon per minute, but in the SI system is a cubic meter per second. It's gallon per minute. That's why that 0.0104 factor comes in to make the Q in gallon per minute. All right, so now we have that, and the formula is given for that was R equal 5.2 ds plus DH, and Q we just talked about. And going back to the this other slide where we have the scupper, there's two different types of scupper. There's a channel type scupper, and those are dimension, and there's a closed system type scupper. And our problem is the open channel one, which is a B. Let me look at the problem again. I believe that's what it is. Yeah, 6-inch wide B channel scupper, yeah. And so to calculate this, basically all we have to find out the load is DS, which is given DH. There's two different ways we can find DH. The first way is by looking at the AAC per the code. Take a look at right here. It's based on this table that's given. And in this table, you can see that you have the Q in our case will be gallon per minute, and then a DH is shown as to be in inches. And there are different type of scupper there. I did a couple of jobs when I built a parking lot. We had the storage for the water itself before we let it out to a drainage system, but they have them on a roof here. And it's the same law apply for, and depending where you are. So you gotta make sure, find out the local code, what they require. All right, let's go back to the problem. So now in the problem we had we have Q is equal 0.0104 IA. So area is given, I is given, and let me just write out here. Q is equal 0.104 times I, and I was given as 3.75, and A was 3,000, and so Q is going to come out to 117 gallon per minute. Now, look at the table. Let me bring that table up here. And in the table, we find for a 6-inch wide scupper, we have Q equal 90. Okay, so for Q equal 90, we have DH is equal 3 inches. And then for Q, the next one over we have is a Q equal 140. And DH is equal 4 inch. But our Q is came out to 117. Where's the column I'm looking for? So our Q is equal 117. Well, then what is my DH? Okay, well, we're going to use a linear interpolation. I bet you forgot. Take a look what I have on a board, and that's how you do a linear interpolation. So y is equal 140 minus 117, and that's plus, there's a multiplication here, 3 right here, I forgot, 3 plus 4 time, that's the 3-inch time those, and 4-inch time the 117 minus 90 divided by the difference between 2, which was 140 minus 190, and I got 3.54 inch. And so we're going to come back, calculate R. R is equal 5.2 times ds was given as, gotta go back to the problem here, 3 inches and plus 3.54. So our R comes out to close to 34.3 pound per square foot. Now remember, when we have this, last lecture we talked about if you're using that for a column, you got to convert that to the kips. And how you do it, you multiply by 3 area and divide by 1,000. But that was the first method to calculating DH. There's another way you can do DH. And take a look at the table. I have these two formula, which is based on that table, basically. Is equal 2.9 times 6 times DH by power 1/2. And then, of course, we have Q, what came out 117. I got 2.9 times 6 times DH by power 1.5. And you can figure that out. And DH comes out, in this case, I get 3.56. It's pretty close to the other way. This is it. It wasn't really that difficult. If you like this, and please subscribe to my channel. And until next time, stay fit, stay active, and be well. And go ahead and do 50 push-ups. If you can do it in 30 seconds, beat my challenge. If you don't know what that is, go look at one of my videos. Take care.